I've had several questions about factoring by grouping. So I want to do a couple examples that have 4 terms and a couple examples that have 3 terms. And I'll also go over sums and differences of cubes. Before I get started, I want to make sure that you understand the rules for factoring using greatest common factor. So GCF, that's greatest common factor. There may be a rule that you're not aware of, which is the sign of the greatest common factor matches the sign of the first term. And that's important when you're using grouping. Here's what I mean. If I were factoring negative 6x squared plus 24x. Well, the only way I'd factor that is with greatest common factor. So I need to know what's the biggest thing that these two terms have in common. And that would be, they both have an x, at least one, so I can factor out an x. And they both have a 6 or a multiple of 6, but I need to make sure that I factor out actually negative 6 because this first term is negative. When you factor, you divide and we'll simplify, and you balance that by also multiplying. The difference with simplifying these two terms here for an expression and when you divide, when you have an equation, is I can divide on both sides of my equation. But this is an expression and I only have one side. So I need to make sure to, if I divide so that I can factor something out, I also multiply. This can be rewritten with the negative 6x out front. If I simplify here, negative 6x squared divided by negative 6x is x, positive x. And then 24 divided by negative 6 is negative 4. X divided by x, the x's will be eliminated. So negative 6x squared plus 24x is equivalent to negative 6x times x minus 4. This is fully factored. This first term, when it's fully factored, should always be positive. Oh, sorry, ran out of room there. And I should be able to distribute this back in and go back to the original expression. So just want to make sure that that gets addressed for greatest common factor before we get started. Okay. And I have 2 examples here. Here's one. Please write this down. 28x to the third plus 35x squared plus 4x plus 5. We'll factor this using grouping. First thing you do is check all the terms to determine, is there a GCF? Is there something that each of these, all 4 have in common? So all terms, whether there are 4 or 3 or 2 or whatever, do they all have a factor in common? And for this one, there isn't anything. And next, I put the terms in 2 groups. So for the problems that I give you, you will be able to factor them you do first two terms plus second two terms. So that's how we'll plan that. You can also rearrange them a different way if there's a pattern that you notice and you want to rearrange your groups a different way. But it'll always work if you do first two. So 28x to the third plus 35x squared plus second two, 4x plus 5. I left a little bit of extra space here. That's so that when I go through all of my steps, I don't have to completely rewrite the polynomial every time. You always add your groups. That's important. Okay. Now, I have two groups. I want to see what this group, what the GCF is, and also for the second group. So factor GCF from each group. My greatest common factor for 28x to the third and 35x squared is 7x squared. So I divide each of these terms by 7x squared, and I multiply also by 7x squared to balance that. The second group doesn't appear to have anything in common. I don't see a GCF, but you can divide anything by 1. So whenever you don't have a common, if no apparent GCF, factor a 1. Okay. So my factors are 7x squared for the first group and 1 for the second group. Let's go ahead and simplify these in parentheses, and we should notice something. If I rewrite this expression, I'll write 7x squared times 28x to the third divided by 7x squared is 4x plus 35x squared divided by 7x squared is 5. And I'm going to add 1 times 4x plus 5. My next step says factor a common binomial. You'll notice that the first group and the second group have a binomial in common. It's 4x plus 5. So here's what I'm going to do to deal with that. I'll divide the first group by 4x plus 5. And I'll divide the second group by 4x plus 5. And to balance that, I'll multiply by 4x plus 5. I can simplify this now. If I'm multiplying by 4x plus 5 and dividing by 4x plus 5, this will be simplified. It will be eliminated. Really, it's just moved out to the side. So then I write what I have left, which is 7x squared plus 1 here, and 4x plus 5. And then I look and make sure that I didn't miss a GCF or some other pattern that I can factor. And here, these two terms have nothing in common. I can't factor this any further. And same for this one. So I am not able to factor again. I'm finished. To check yourself and make sure that your factored expression is equivalent to the original expression, one way you can do that is to graph them. So here I have 28x to the third plus 35x squared plus 4x plus 5. and type that into Desmos, or you can use a graphing calculator. And your graph looks like this. And my factored expression was these two binomials. And you can see they graph right over the top of each other. So they are equivalent. This won't tell you whether your answer is fully factored. You might still have factoring to do. However, it will tell you whether you are currently or whether it's factored correctly. Here's another example. (16x to the third plus 64x squared minus 10x minus 40. First step, do each of these terms share a common factor? They do. It's 2. So I'll divide each of these terms by 2 and multiply by 2 and just move that 2 out. And I need to simplify this now. So I can rewrite my expression as 2 times 8x cubed plus 32x squared minus 5x minus 20. I need to put my terms in 2 groups. I'll do first 2 plus second 2. First group is 8x cubed plus 32x squared. Leave a little space here. Plus negative 5x minus 20. I have a negative, I keep it with the number so that I can add my groups. Next, factor GCF from each group. In my first group, the common factor is 8x squared. In the second group, my common factor is negative 5. I need to simplify these. When I do, I need to make sure that I bring my 2 along. So rewritten, this is 2 times 8x squared times x plus 4 minus 5 times x negative 20 over negative 5 plus 4. My common binomial is x plus 4. So if I bring this out front and take it out of the groups, that leaves me 8x squared minus 5 times 2 times x plus 4. It doesn't matter what order you write these in because they're all multiplied together. So, and then I verify that I don't have anything else to factor. These terms can't be factored. This can't be factored. I'm finished. If I had not factored out the 2 in the beginning, then when I got down to the end, I would have a 2 to factor out. I could do that last instead. That's your choice.